about optimizing building energy with AI. The personality is going to come up next. He's the founder and CEO of Zodhya, an energy tech or a prop tech started from India that's redefining how buildings use and manage energy. Now, under his leadership, from what I know, Zodhya has built an AI-driven technology stack that enables commercial and and industrial facilities to reduce energy costs and emissions by up to 30%, delivering measurable efficiency improvements from the very first day with zero infrastructure changes. An IIT Madras alumnus with over 8 years of experience spanning entrepreneurship, energy systems, and product designs, Rohith, the one who's on the screen, has built global partnerships with client investors and sustainability networks. Driven by passion for solving real world energy challenges, he is leading the movement to make AI powered energy uh, optimization accessible, scalable, and impactful, and helping to build environment transition towards a smarter, resilient, and a low carbon future. Let me remind you of the topic once again: optimizing building energy with AI. Give it up for Rohith Pallerla. Rohit, the screen is all yours.
Yeah, thanks, Gaston, for the very good introduction of me. Pleasure to meet you, Naresh and Abdul Salam, and thanks, Tech Guide, for inviting me to give a speech on this. Um, so maybe I share my screen and then explain what our experiences have been when we started working with buildings, how the energy landscape in these buildings is changing, and what AI can solve as we go forward as well. So, yeah, is it visible?
Yes, we can see it now.
Yeah. So just to give you a brief, at Zodhya, I'm one of the founders at Zodhya. At Zodhya, we work with buildings, both commercial and industrial buildings, in optimizing energy with the technology we have developed, and we are deployed today with more than 75 buildings, more than 80 buildings, um, with our solutions resulting in at least 2 million units per month in terms of energy reduction for our clients, and emission reduction as well, because energy and emission are closely related. Close to 1.5 million kg CO2 of emission reduction was also happening per month for our clients cumulatively. So yeah, so what's with energy and buildings, right? So when you look at any given building, what we have seen is the larger the building, the larger the business, they end up having the larger energy bills as well. And this has been particularly been affecting businesses which have high infrastructure exposure, affecting their operational expenses anywhere between 5% to 30%. And that, in fact, created interest in us as well to see what can be done. And we wanted to look at what exactly is causing these high energy bills, right? So when we looked into this, we understood there are a few set of reasons that's leading to that. So the first thing is penalties which they might end up facing with respect to energy regulatories. And then these buildings, the larger the building, or it could be smaller buildings as well, leading to higher energy consumption. And then there are different set of energy losses that happen in the building which is leading to that. And this is an interesting thing. So excess energy usage, so using more than what is required, which nobody thinks they are, but you end up doing that. And then you use more energy when there are utility tariffs are high, when peak tariffs happen as well. So these are like some of the reasons leading to those high energy bills. So the first part of this presentation, I will be focusing on uh, exactly into what exactly is causing these uh, high energy bills, and then later see how AI is able to solve most of those scenarios. So when we talk about penalties, right? So there could be different set of penalties which utilities charge on, like from depending on which part of the world you are in and which kind of utility you have been contracted with, and there could be one-to-one different contracts as well when we talk about businesses. But predominantly, there are three different ways in which utilities try to penalize you, because that's also impacting the way they plan their own. Uh, uh, supply demand as well, right? So one is in terms of power factor. It essentially means uh, for the given supply power, how effectively the power is being utilized at your facility. So let's just say if I have to take a parallel example, it's about buying a liter of water bottle, right? So if it's filled to the brim, that means it's like you're completely utilizing that bottle as a whole. But if it's not, then you're not utilizing that, right? So that essentially what power factor is. And then contracted demand is the demand you have told the utility that you will be procuring it from. But let's just say if you're procuring or you're utilizing more than what you have stated that you will procure from, then utilities haven't planned for that, so they would want to penalize for that as well. And the third thing is dependent on a geographic or a compliance specific, where they might also want to charge you based on energy intensity. So it's nothing but how many units are you using per square meter, maybe per over a year of period. So here I have a snapshot of one of the clients energy bill we work with. So just wanted to give you a brief understanding of how these work. So here, if you look at the power factor, it's about 0.991. So typically, power factor values vary between 0 to 1. The closer you are to 1, the better it is. And this building is much better than most buildings out there. And in terms of contracted demand, this building has contracted for 2000 kVA, but they are ending up spending at the maximum demand of 1175 kVA for this bill, which they have received from. And then in terms of energy intensity, so this is an office building, Department of Energy US, and there are a few organizations across the world, depending on the geography again, which uh, suggest what kind of energy intensity should a building be operated with, depending on the sector and depending on the climatic zone they are in. So typically, it's between 100 to 150 units per square meter per year is what they would suggest in. And this building is ending up at about 74 units, which is quite comfortable. Good. So it wouldn't face any penalties in a usual scenario, but if any of your buildings are not meeting that, then you might be positioned to do that. Then there are energy losses. So this is an interesting thing which happens at buildings, right? So these losses could be at different levels. So the moment power enters your building, there could be uh, different ways of these losses happening, because there could be a wiring issue, there could be a design issue, there could be a faulty equipment which is operating, or aging equipment, or there are certain equipments which induce uh, different uh, harmonics, technically speaking, but it's kind of back currents which might be induced into the grid as well. So these could lead to energy losses, and there are other side effects as well which might damage your equipment or health of your equipment as well. So typical reasons or tip I mean, I would say easy to pick out energy losses is in terms of if you are having a low power factor, that means you are not utilizing the power which is being procured by that equipment level. So if you are able to measure that at a zonal level or equipment level, that could give you a better idea. And then the other kind of loss which is easy to identify is in terms of imbalances. So most most large buildings or mid-sized buildings, they would have a three-phase power supply, and you would ideally want those currents flowing in each of those phase to be of equal magnitude. But if they aren't, then that would lead to a neutral current which is flowing in, and then also a phase imbalance, which means an energy loss as well. Then this is an obvious thing to look at. So how about the excess energy usage, right? So let's just say if equipment is rated about 45 kilowatt in this scenario, but the moment it overshoots that rating, then that means the equipment is getting overloaded. There could be multiple reasons here again, because with aging of the equipment, this could be again into the picture, but it could also be you're putting more load into the machine, or there could be certain other reasons which is leading to high energy or overload than what it is rated with. And then the other area where we've usually seen this excess energy usage happens is in terms of HVAC systems, which power your heating or cooling systems. And here, the reasons could be multiple when it's leading to excess energy usage. Typically, we talk about thermostat setting, which is leading to high energy usage. Having optimized that, there could be multiple other scenarios in the way, because these are complex systems, and there is always a thermal demand which keeps changing based on your environmental factors, based on your occupancy, based on the efficiency of the system itself. And uh, that's where mechanical and operational inefficiencies creep in, which could lead to excess energy usage than what it needs to be. And when I talk about the peak time usage, so peak times are nothing but the timing at which the specific utility at your geography, or the utility which is powering your building, um, might give you a higher utility tariff than usual. The reason from the utility is because during those time periods, it's tough for them to arrange for the supply that is going to meet your demand. So that's why they charge you high, in the hope that you would reduce your power consumption during that time. But if you're not, then that leads to again higher energy bills. So that's essentially how the consumption during peak times can lead to higher energy bills. And then there is another factor which also comes into the picture, which complicates your peak time usage. So that's having solar or wind at your facility. Now, every building is going with on site solar, in fact, battery systems. And then you also are getting EVs into the picture, where the charging of the building's grid. And when these scenarios are happening, and with renewable sources, one thing is unpredictability is what they go with. So when these unpredictable timings happen, how is your energy being planned also affect your energy bill that is coming out from the grid. Now, having stated all these problems which are happening in terms of energy, now why is this a tough thing to fix, right? So when we talk about water problems, it's visible to the eye where the problem is. So thereby you go there and fix that. But with energy, that isn't the case, right? Because it flows through the wires, you can't see it with your eye, and it's, I mean, not with your naked eye. Then what do you do about it? And most of the measures, when we inherently take them, is more like a reactive measure, because once we know, okay, there's a certain downtime with an equipment, or a certain uh, temperature uncomfortability which happens with HVAC systems, or let's say there is a problem with their generation equipment, that's when we go and take some reactive measures, which we need to do that at the end. But can we be more proactive is the question here. And when we try to do that, it becomes a complex thing to achieve, right? Because when we talk about energy in a given building, as we've discussed across all these problems, the complexity is a lot, because there are a lot of systems operating together at the same time, each equipment operating uh, at their own patterns of consumption, patterns of electricity flow. And then there are different demands and requirements you want from each of the equipment, or each of your specific buildings. So when things become complex is where now we are seeing that AI is able to solve that. So now, how can AI help you in this? So the first thing which uh, you need to ensure, to be in a position to take advantage of the AI that is out there, is having the ability to map the energy flow across the building. A couple of speakers who have spoken earlier also have touched upon how they are able to bring in new communication systems, cyber secure systems, that are enabling these data point collection. But essentially, what you would need from any system to start optimizing your energy in buildings is, can you bring in uh, a device or architecture or some solution that can help you map the energy flow across all your critical points, or all your points across the building. So that's one point to start how AI can optimize your building. And once you have done that, one of the easier things to do is map the flow across that building, across several equipment, and then see inherently what are the different inefficiencies that are happening. Some of these could be rule based, right? So some of the problems which we mentioned about overloads and things like that, these are certainly rule based. So if it goes above a certain threshold is where you would want things to get notified and things like that. But there could be a lot of different intricate issues as well. uh, One area where AI is also helping is, let's say you find out an inefficiency. What's that inefficiency about is also something which AI today is able to solve or help you solve that, right? Because let's say there is an overload of the equipment which we were talking about. But if there is an overload, there could be multiple of reasons. It could be because you yourself are overloading that specific equipment, or there could be an aging of the equipment, or it could be uh, a wiring issue which is leading to that, or heater element which is leading to that. Now, depending on the pattern of the consumptions, is where now AI today is able to help you identify what's the root cause for that, and then help you identify that this is the inefficiency and this is how it can be fixed as well. And this other part, when we were talking about heating or cooling systems, which are predominant in buildings, right? Today, about 60 to 70% of our energy usage profile is driven by heating or cooling systems. Now, when these systems are operating, one of the optimization things we always look for is user control of stating at a specific temperature. It could be 24 degrees centigrade or maybe 75 Fahrenheit, depending on the kind of geography or compliance you need to follow with. But that itself is not addressing your energy consumption of the HVAC, because there could be a lot of different factors, because the thermal load inside the building is always changing. Now that's where AI is also coming into the picture, where it is able to in real time able to see what your thermal demand requirement is, and based on that optimize different components of your HVAC system so that it meets your required room level or floor level temperatures, while ensuring that it leads to lower energy consumption as well. Now, having spoken about the usage level, uh, now AI is not just stopping there. It's also addressing how the supply at the given building can be done better as well. Now, when you have different sources of power, which is one of the scenarios where we discussed, it could be on-site solar, some battery systems, and when you have EVs also, which do have batteries, maybe vehicle to grid technology, or maybe vehicles where you need to just charge it off the building's grid. Now, at what time do you charge them so that uh, there is not much load on the grid, or let's say you're not doing that during the peak time tariffs as well, right? Or you're charging them when there is more solar that is available, or can you maximize the solar that is being generated on the building that can be utilized back into the building, rather than let it get wasted out. So when we have done that, so we have realized like AI is also helping in those scenarios where it's helping you schedule different sources of this power supply, wherein your payback period on those on-site systems is also reducing, and also the energy bill on the grid is reducing. And not just that, right? So once you are able to get a hang of it, you can flip the script and then say, how do I get more advantage by trading my excess energy to the grid, and then make profit out of it. So that's also something where AI is enabling today to do that for all these buildings. And this is not just all theoretical, right? So, I mean, over across all our deployments, we have deployed different set of AI, which I have just discussed, and I will be discussing a few case studies as we go forward as well. But as you can see, there is a tangible bill reduction across all the clients we have worked with on an average 25 to 30% here in this snapshot, which I'm sharing. It's close to 30% in terms of energy reduction, which they had. And one good thing with respect to energy reductions, right? So it is also resulting in lower emissions, lower scope to emissions, and both environmentally good and financially good. And what better solution than this, right, for any given building? So I'll be sharing a few case studies of few of our AI solutions which have been deployed across different sizes of buildings, different case scenarios, and how it has helped them. So here it's an office building, about 12 floors, G plus 12, and building size close to 45,000 square meters, more than 500,000 square feet. And here, the purpose of our solution was to optimize their HVAC systems. This being a office building where their usage profile was going over and above 75% in terms of HVAC consumption. And once deployed, we call it SaverX internally, but once our solution was deployed, we have seen that the solution has resulted in close to 25% energy reduction for the HVAC while maintaining the thermal comfort which the client was looking for. And this is for an airport which we've done here in India. And for the entire passenger terminal is where the solution was again deployed to optimize their HVAC systems here again. And we've seen close to 15% reduction in terms of energy reduction via their HVAC systems. Now, this is an interesting case study again. So, where this is a factory which is into packaging, textile, and packaging, and this being an industry with different varying loads, machines which operate at very high loads, they had different distributional energy losses which were happening, which were leading to downtime of the equipment and higher energy bills than their usual operated or usual estimated consumption led to. Now, once our solutions were deployed, the solution was able to identify what's the root cause for that, where these inefficiencies were happening, which of those equipments or zones were the culprits that were leading to that, and what can be done with respect to that. So, one good thing about such solutions is it's not about just identifying what's the root cause with it, but also coming up with a recommendation saying, hey, this is how it can be fixed so that your problem is addressed. And by doing that, this client actually saved close to 15% on their energy bills. Now, this is an automobile manufacturing plant, about 30K USD per month of bill and 300 kilowatt of contracted demand. One uh, particular thing with respect to this plant was they had to run their manufacturing throughout the clock. I mean, 24 by 7, ensuring that cars are being assembled and shipped out. And when they had multiple assembly lines, one or the other assembly line always used to go every fortnight. One typical response is, well, I was saying it's to be reactive, right? So when a problem has happened, you go there, fix it, and or you may replace it and then get things started. But that's not going to support you forever. So that's when our solution was deployed. It was able to identify what was happening in that assembly line, specifically couple of VFD machines which were causing harmonics, or I would say back currents into the entire panel, which was affecting that panel and getting that panel downgraded. So that's when the assembly line had to go down and then they had to fix the problems. Now, where and why this VFD was behaving inherently different was identified by Soul by identifying different electricity patterns that were happening. And once that was a recommendation was because these are VFDs which were specifically designed by an OEM to this specific factory, so they use this data in fact to get it replaced as well. So that's in terms of opportunity cost as well, right? So when you go ahead with the energy optimization, it's not just you're addressing energy losses, but you're also ensuring that there is an equipment or power system health that also comes into the picture, and you also save on the opportunity cost or the repair cost you might end up doing altogether. And this is for building in Tokyo when we worked with. So this is again an office building, about 1200 kV of power demand, and they had rooftop solar about 125 kilowatt and about close to 960 units of battery storage as well. Now, with the typical tariff which is happening in Tokyo and their way of operating the batteries, so they had their payback period at about close to 19 and a half years. But once our AI solution, which was able to optimize the way battery gets charged and discharged, understanding their solar generation patterns and optimizing their energy demand in that office building. So the scheduling tool which we have implemented with this building which was integrated to their existing battery management system as well, has brought down their payback period on those existing systems by about 8.5 years. And in fact, there was significant energy bill that was saved from the grid for this building, close to 33,000 USD. So yeah, so these are like how AI is redefining how energy in buildings can be optimized, and it's yeah. So it's not today like where we need to monitor, but it's about how do we get things going with these intelligent systems that can and in the end benefit our buildings as well. So yeah.
Thank you so much, Rohit. There was some very interesting case studies, and it was very intriguing, right? I let Abdul Salam ask for a question.
Thank you, Rohit, for this insightful presentation. I observed that you have utilized certain case studies from commercial to industrial and also government premises. My question to you is related more into the residential buildings and basically the concern that normally the public has about their privacy and the ethical use of their data. Is this something that you came across as a challenge when you're pursuing your project and product?
Yeah, so it depends on the kind of solution the end consumer is opting for, right? So, in our case, we have ensured that we abide by EU GDPR guidelines. We do not take any personal data when this solution is being processed or even in the deployment as well. But that could vary from solution to solution, right? So there could be some solutions which end up taking control over your cameras, seeing your occupancy and things like that, which we are not into. But this depends on solution to solution. It is also important for the consumer to understand what kind of solution they are opting for, or at least have a brief overview of how that optimization is being achieved, right? So, is it based on your external factors and the energy load? Then it's not relevant to any personal data as such, but is it also depending on your usage behaviors, or let's say your purchase behaviors, or maybe the way you come into the building and go out of the building, things like that. That's when these intricate things come into the picture. So yeah, it's dependent from solution to solution as well. But when it comes to our solution, we have ensured that we do not process any or request for any of such information. So
Thank you.
With that, Naresh, I'll turn the mic on to you. You'd like to ask some questions to Rohit?
Yeah, thanks. Thanks, Rohit, for giving a rundown on various sectors. Indeed, I enjoyed. I'm just curious, I think, given from the previous presenters and what I could take biggest challenges from the legacy systems and the human factor, right? So, what are the biggest technical and organization hurdles you face when integrating these type of AI solutions into these environments, particularly the facility management teams, right? Like they may have openness, like are you taking away my job? That could be one phobia, and are you stealing the thunder and from the OEMs, whether it will have interface and impacts. So I know the simple numbers looks very impressive and it is attainable, but I know that it's not that easy. You overcome that, but mainly to leap over all these hurdles. So can you give us some insights of that, some real case scenarios?
yeah, sure. So I mean, there are two parts to this question, right? So maybe I'll answer the second question first. Is it going to replace any of their jobs? I don't think so, because today, at least the solutions which I presented are not easily solvable by any human person, right? Of course, you would need dedicated source 24 by 7 um, to understand what these patterns are, and then come up with a calculation which will keep changing again and again. And about 99% of the buildings we have worked with, I would say, go ahead and say 99.5% of the buildings we have seen across or out there operating different built environment, it's really tough to do. So that's where AI is coming here into the picture, saying it will make your job easier, while the facilities team can still focus on ensuring that there is the right delivery of energy and other facility sources, which they are mandated to do as well, while ensuring that whatever service is being offered to them in terms of energy is also optimized utilizing AI that is out there. So yeah, so to answer your question there, it's not going to replace them.
The
Yeah,
point is actually it's going to do beyond the human being. I think that's where your system is doing. That's where the phobia can happen. I mean, that's where I was. My context was more on that. It's not that the human can do more than that the AI, right? It is the other way around. So that's the context. Yeah.
yeah, I think at some point, uh, I mean, technology outperforms most average humans. That is true. And here we should be looking at, is it improving my productivity? Is it ensuring that with the workforce which these facility management have, they have a lot of pressure to attain different assets or different areas of a building environment, not just in terms of energy. Now, when you have different scenarios and with a limited workforce, uh, what are the technologies that is going to make your work easier? And this is one such solution which is going to make that happen. And yeah, so that is one, but it's not going to replace it completely, right? So once you identify where the issue is, so I was talking about certain issues. So for example, I was talking about, yeah. So where AI here has identified what's the root causes, and let's say with respect to our technology as well, it comes out with recommendations saying, hey, this is how it can be fixed. But now to fix that is where you always need a human. So because these are complex systems, where it needs manual fixing, not never can be done by a machine. And the other area where human role is still important is to understand what the design limits of the system are, and ensuring that the solution that is implemented is operating within those threshold limits. So to answer your second part of the question, as long as we are ensuring that, be it with respect to any other AI out there or with respect to our own solution which we deploy, as long as it's operating within the operational and threshold limits of that certain building, then AI will definitely do your job better. But the purpose here is to ensure that it is operating within that. The moment it goes out, it could lead to different hazardous scenarios which um, may not be controllable by any given building operator, right? So whenever we work with any building, we do have our checklist of operations and deployment. Pre-deployment checklist is what we have. So we ensure that when we work with any given building, that the AI is tuned to operate within their threshold design limits and operational limits. By doing that, we are ensuring that once it goes into deployment, it is not voiding any of their warranties, as well as operating within uh, the safe limits of how this systems should be operated. So yeah.
So the buy-ins, there is no restrictions from accepting the factors, right? That is not there from a facility management wise.
Yeah, I think as long as you're operating within those safe
The
limits, right?
limits,
So yeah,
thresholds, yeah.
yeah.
Okay, understood. Over to you, Gaston. Thank you. Thanks, Rohit.
Thank you, Naresh. Thank you, Rohit. While some people say that AI might replace 100 jobs, but they also say it'll create 1,000 more. Well, thank you so much, everybody, for who joined us today for this insightful and forward-looking discussion on AI and sustainable energy. It's been an incredible session filled with ideas, with innovation, and of course, inspiration. A big thank you goes on to all our distinguished speakers, the incredible ones, Ronita, Tanish, Rajesh, and Rohit, for sharing their expertise and perspective. They've truly helped us understand how artificial intelligence and energy can play a key role in creating a cleaner, more efficient, and sustainable future. I cannot stop by thanking Naresh and Abdul Salam for consenting to co-chair this session and for this wonderful question that gave us a wider perspective on the topics that were shared. And of course, heartfelt thanks to organizing team and those working behind the scenes to make this event an absolute wonderful success. Today's dialogue, as I close, reminds us that technology and sustainability aren't really separate paths. When guided by purpose, AI can help us optimize energy systems, reduce waste, and empower communities to make smarter choices for our planets. As we sign off, let's carry forward the spirit of innovation and collaboration. Let's continue to explore how data, intelligence, and human creativity can drive meaningful change. On behalf of the entire team, thank you once again for being a part of the discussion. Stay curious, stay inspired, and let's keep shaping a sustainable future, of course, powered by AI and driven by all of us. Have a wonderful time ahead, and we look forward to connecting soon. This is Gaston D'Souza signing off with a good night.
Thank you, Gaston. Thank you, Abdul Salam. Thank
Thank you
you.
very much.
Thank you,
Pleasure.
Naresh.
Bye.
Thank you.
Thank you.